We're going to start our new unit today. We're going to take a look at solving quadratic equations, and we're going to start by taking a look at how we find the solutions by graphing. So if you remember, we took a look at quadratic functions in the last unit, and we have a couple of different forms of our quadratic function. First of all, standard form, where we have y equals ax squared plus bx plus c, and we have vertex form, which we've used quite a bit in the last unit to graph our quadratic functions, and that's in the form y equals a times x minus h squared plus k. So we are now going to take a look at what happens if we know what our y value is. So the equation of a quadratic is in the form ax squared plus bx plus c equals 0. And we know that a, b, and c are just integers, any number, no fractions, no decimals. And we now know that that equation has to be equal to 0. So we've replaced y with 0. Now, a cannot be equal to 0 because if that was equal to 0, then we no longer have a quadratic function. We would just have a linear equation, So a quadratic function has y in there, and we have all sorts of points that satisfy that function, whereas a quadratic equation now has an answer of 0. So we know that y is equal to 0. So what we're doing is taking a look at what values of x are going to give us an answer of 0 for y. Okay, so what points on a graph have a y value of 0? If we think about graphically, we know that y is 0 where we have our x-intercepts. So to solve a quadratic equation graphically means to find the x-intercepts, or where our related function crosses the x-axis. And they can also be called the zeros, so you'll hear them referred to as the zeros, or the solutions, or the x-intercepts. So we're going to take a look at manually graphing. So solving by graphing, we cannot graph an equation. We have to graph the related function. And we have to write this part because we know that in order to graph, we are looking at the function, not the equation. So what we're doing is just putting our y back in there in place of our 0. So we know to graph this function, we already have our vertex form. And our vertex is at -3, -4. So that's exactly where we're going to put our first point on our graph. And we notice that our a value in front of our brackets here is 1. So we know that we're going to follow our regular old pattern for graphing a quadratic function from our vertex, over 1, up 1 on either side. From those points, we go over 1, up 3 on either side. And from those points, we go over 1, up 5 on either side. So we can now graph our parabola. And as always, we put arrows on the ends of our parabola and we label it with the function. Again, we don't label it with the equation because we can't graph an equation, only the function. So now we're focusing on the spots where our parabola crosses the x-axis. And here we know that our solutions then are -5 and -1. So we have two different solutions that an x value of -5 will make our equation equal to 0, or a value of -1 will also make our equation equal to 0, the left side of our equation. And if we ever wanted to check that, we would do a left side, right side from the equation itself. and sub in our x value to prove that the left side is also equal to 0. So part B here again, we're going to start with our related function. So y equals -2 times x minus 5 squared. And we know that our vertex here is going to be 5 and 0. So again, we're going to start with our vertex on our graph, 5 and 0. We notice that our a value here is -2. So we are going to be opening down from our vertex, and we're also going to have a stretch by a factor of 2, which means that we're going to go over 1 down 2 on either side of our vertex, over 1 down 6 on each side of those points. So again, we're going to draw our parabola in here. Make sure our arrows are on the ends, and we're going to label with the function. So y equals -2 times x minus 5 squared. So noticing that we only have one value, one x value that will make that equation true then. So we have, therefore, the solution is 5. There is only one x value that will make that equation equal to 0. Okay, part C, x squared minus 2x plus 3 equals 0. Notice that we don't have vertex form. So we are going to have to complete the square in order to change this function into vertex form. So first of all, we start with our related function. And we do again have to write that in there to show that we are aware that we cannot graph an equation. So completing the square, we notice that we have an a value of 1 already, so we don't have to factor anything out of our x squared and x terms. So we're going to start by adding and subtracting a value that is going to create our perfect square trinomial here. So half of -2 is -1. -1 times -1 gives us +1. So we add 1 and subtract 1 in order to create our perfect square trinomial. Now we're going to factor and simplify. So we've got x minus 1 squared plus 2. So we now have our function in vertex form, and our vertex is 1 and 2. So first point on the graph, 1 and 2, we know that our a value is 1. So from that point, our vertex, we're going to go over 1, up 1. From those points, we're going to go over 1, up 3. And those are the only points we can fit on the grid, so we're going to graph those 5 points. And we're going to draw our parabola. Again, arrows on the end, and labeling with our related function. Now, we notice that our line or our parabola does not cross the x-axis. So we have no x-intercepts here. So that means that we have no solutions. We know that it's never going to cross the x-axis if it starts above the x-axis and opens up, or if it starts below the x-axis and opens down. So, in summary, in order to solve a quadratic equation by graphing, we state our related function first. Once we have that, we make sure that it is written in vertex form, if it's not already. And we do that by completing the square, which we went in depth in the last unit. So we completed the square, and we're going to graph the equation using the vertex. And again, we get our vertex from h and k in our vertex form, and we use our pattern to find the other points. And we're going to solve by the roots by finding the x-intercepts from the graph. and then we just state our solution. Now, we also notice from our 3 examples that we have 3 different possible outcomes. When our parabola starts below our x-axis and opens up, or starts above our x-axis and opens down, we have 2 distinct real roots, which means we have 2 different x values that satisfy the equation. If we have a parabola that opens up starting on our x-axis or opening down but still starts on the x-axis, then we call that 2 equal real roots. And we'll talk about why we have 2 equal real roots in depth in our next lesson. But if we only have one x value and our vertex is starting on the x-axis, then we have 2 equal real roots. In case number 3, we have a parabola that starts above the x-axis opening up or opening down but starts below the x-axis, then we have no real roots or no solutions. Okay, so that is the basis of solving our quadratic equations by graphing, and that's it for today.